just when I thought I was done making videos, I saw this question and thought I'm going to make one more in case you're running out of practice ones and you want to try one more before you take the test. This particular question was on a calculator allowed section. It was on the 2009 test, but it was on the Form B, which is essentially what happens if a student has to take a makeup exam. They give a test a couple weeks later, and they don't give a lot of data about that test. It is known to be harder, so if students take a makeup test, they tend to be faced with a harder test, but I do not know the national average on this test, but I'm guessing just by looking at this question that it would have been pretty low. I do have the rubric, so as we go through and do this question, I will talk about where the points were assigned to get the 9 points. So this question is dealing with a tree trunk, and the tree trunk has a circular cross-section, and we have an equation that represents how the radius is changing. We have the derivative of r, dr dt, and it has a pretty complicated function, which is definitely something you want to put in your calculator because you're allowed to use a calculator, and I ended up storing that as y1 the whole time. It tells us that at time equals 0, the radius of my tree trunk is 6, and it tells us that the area of the cross-section is always going to be referred to as a of t. Asking us to do 3 different things. I like this question because it's a differential equation type question, which tend to be very common and very challenging, but it's a little different because it's not a separate and integrate. The first thing I noticed right away is that my dr dt is all in terms of t. What that means is I do not need to separate. There is no r piece that I need to divide and get it on the dr side, so that makes it a little easier, but they ask a different variety of questions than sometimes some of the normal questions. So we're going to go through each part. Each part is worth 3 points, so as we go through, we'll talk about what you had to do and how you earn the 3 points for each part. So part A. Part A wants an expression using an integral, so they give you a little clue, for the radius from 0 to 3. So the first thing that I look at is if I have a derivative of r, the way I get r is I'm going to integrate. So it's going to the integral of dr dt, so 1/16 3 plus sine of t squared. And the other thing that I know is we are wanting to know the radius from 0 to 3, so they're actually giving me the boundaries, so from 0 to 3. And then I can go even further and do a fundamental theorem of calculus, which shows up multiple times in this problem, and say that if I integrate dr dt from 0 to 3, I'm going to get r of 3 minus r of 0. You get 1 point for setting up the integral. So 1 point just comes from realizing that you need to integrate from 0 to 3, the 1/16 3 plus sine t squared. At that point, you also get a point for going through and actually figuring out what the integral value is and what r of 3 is, so going a step further. Here's where your calculator comes in. So right at this point, I'm going to go to my calculator, I'm going to go to y equals, and I'm going to type in my dr dt into y1 so I can kind of have it stored there for the rest of the problem. Make sure you type it in correctly. You don't want to miss points because you didn't have it typed in correctly. So 1/16 times 3 plus the sine of x squared. And I'm going to quit out of that. I'm going to figure out what the integral value of that is. So using math 9, going from 0 to 3. Put in that equation, so using that vars menu. So I get 0.610. And also what I did when I did this problem is I wrote from 0 to 3 of this whole 1/16, and you could just write dr dt in here, or r prime, if you don't want to rewrite this equation over and over again. I wrote that if I take that and then I add r of 0, I get r of 3. And at this point, I can just go in and say, okay, I know r of 0 is 6, because they tell me that at the beginning of my problem, that at times equals 0, the radius equals 6. I know this value is approximately 0.611 or 0.610. Add them together, I get 6.610, or 6.611. So for this, you get 3 points, 1 for setting up the integral, 1 for having a correct expression using the right notation, using that fundamental theorem, and 1 point for actually saying that r of 3 is this either 6.610 or 6.611. For part B, also worth 3 points. Part B wants to know the rate at which the cross-sectional area is increasing at a time of 3 years. Now, when I first looked at this problem, I saw the word cross-section and thought, oh, we must be doing a volume problem. But then I read it again, so you don't want to just look at it once. Make sure you're looking at it again. This has nothing to do with volume. This just wants to know how the area is changing, and it just happens to be, because I'm slicing my tree, a cross-sectional area. So first thing I wrote down is an area formula for a circle. And if you want to be more specific, we can, instead of r squared, I can say that it's actually this r of t function squared. And you get 1 point for that. 1 point for just realizing that if I want to work with area and it's a semicircle or it's a circle, then it's just pi r squared. I would take the time to replace r with r of t just to use the notation they did in case they get picky and want that notation to be correct. Then I realized this is actually a related rate problem because I want to know how is the cross-sectional area changing, and I already know about how the radius is changing from what I did in part A and what they gave me in the problem. So when I take the derivative, I get dA dt equals 2 pi r, so r is r of t, or you could just write lowercase r if you want to use that to refer to your radius, times dr dt. Now we're going to see what we know. What can we actually plug in? Because my goal is to have dA dt by itself. So first of all, I want to figure out, I'm looking at time equals 3. So I have to figure out the radius at 3, which I actually just did. And I need to figure out what dr dt is at 3. So kind of using notation, you could write it like this, and you could put like a little 3 down there if you'd like. Or you could just punch it in your calculator, because you are allowed to use a calculator. At this point, I'm going to take what the r of 3 was. It was this number plus 6. And just to have it in there, I ended up storing it as x. Just in case I need to use it again, or because I know I'm using it in this part. So when I want to find dA dt, it is going to be 2 times pi times this r of 3, which I stored as x, times my dr dt when I put 3 in. And the way I'm going to do that is I'm going to take that original equation they gave me, which was dr dt, and I'm just going to replace the t with 3. So I did it all in my calculator all at once, and I typed in 1/16 times 3 plus the sign, and it's the sign of t squared, so if I take 3 squared, it would be 9. And I get a dA dt to be 8.858. You could call that dA dt. You could also call that a prime of t. They did ask for unit, indicate units of measure. Since this is how my area is changing, it is going to be centimeters squared per year. Because my radius was changing at a rate of centimeters per year. So my area would be centimeters square centimeters per year. This was worth 3 points. So to give you an idea of what they were looking for, they were looking for 1 point to write an expression for A. 1 point for writing an expression for A prime, so this line, and then 1 point for your answer. So you didn't have to show a lot of the in-between computation because you were using your calculator. And 8.858 was what they were looking for with 3 decimal place. And then finally part C. Part C also worth 3 points. Part C wanted to evaluate the integral from 0 to 3 of a prime of t, use the appropriate units, and explain what the answer actually means in terms of the context of the problem. So the first thing I wrote down is if I integrate from 0 to 3 of a prime of t, I would get a of 3 minus a of 0. So the idea, again, that I'm using that fundamental theorem of calculus. You got 1 point just for writing that statement. So once you wrote that, that's a point. To finish it, I need to figure out what a of 3 and a of 0 are so that I can then turn around and subtract them so I can get an answer for the integral and then interpret what that answer means. So my area, I kind of came off to the side and said, my area is pi r squared. My radius at 0, so I started with this piece because I thought it was easier. My radius at 0 was 6. They told us that in the problem. So this I'm going to replace with pi times 6 squared. To figure out my area of 3, well, I already know that my radius of 3 was the answer that I got in part A, which was already stored on my calculator. It was at 6.611 or 6.610. So I would have pi times approximately 6.610 squared. When I go to my calculator, since I already stored that number, I'm going to type it in like this. So I'm going to have pi times what I called x squared minus pi times 6 squared, I get 24.200 or 24.201 was accepted. They were both listed as acceptable answers, so if you had ended in a 0 or ended in a 1. And then finally, the last point is what does this mean? And what it means with appropriate units is this is how the area has changed. So if you integrate to accumulate, if you integrate the rate that the area is changing over a time period, it tells you how the area has changed over that time period. So to finish it off, I put the right units, that this would be an area change, so it would be centimeters squared. And I wrote that this is the increase in area from the time equals 0 to the time equals 3. And to get the 3 points, 1 point came from the very first statement that I wrote down before you really plugged any numbers in it. 1 point came from this value. Even if you didn't have units, if you had the 24.200 or the 24.201, you got that point. And then the final point came from having the centimeters squared, understanding what the unit would be, and explaining what that means. So with this problem, my guess is, even though it wasn't that bad when you go through it, my guess is the national average would have been pretty low on this one. Again, they try to make things a little more challenging with their Form B tests, and there are so many situations where you might look at it and think it's something that it's not. For example, you might look at Part A and think you have to separate to integrate, which you don't. You might look at Part B and think you're doing a cross-sectional volume because you see the words cross-sectional, not realizing that it's actually a related rate problem. Part C, to me, probably is the easiest to start, but if you don't get the answers correct in Part A to plug in, then you won't be able to actually finish the problem. But definitely a very easy point to start Part C, just to write the fundamental theorem of calculus. So that, I think, will be the last review problem to get you ready for the test, and I think by now we've done so many examples, you've seen a little bit of everything, so you are ready on Wednesday.